Good morning, everybody. Welcome to this morning's session about how to build your platforms and cloud-native systems if you are just starting out, or if you are just building a product, or maybe you are far further along on the journey. But yeah, how to save your future self from your current self. My name is Natalie Godec. I'm a principal cloud architect at a company called Zencore. I'm based in London, originally from Ukraine, and the company is a services company, which means that we build cloud platforms for other companies around Europe, in the US, and so on. Which means that I've built quite a few architectures. My job is to imagine how to solve your problem with Google Cloud specifically. We're a Google Cloud partner. And I'm also a Google developer expert, which means that I love the technology that I work with so much that I can't help but talk about it. And the QR code leads to my social media, but it's not very sharp. Oh well. A little bit of context, a little bit of mise en scène. This talk was born out of a conversation with a Ukrainian DevOps engineer who booked a mentoring session with me through a platform called Projector. Projector is a Ukrainian educational and training platform, and their mentoring system raises funds for humanitarian efforts and defense forces of Ukraine. So this DevOps engineer, who found themselves in the architecture position at their startup, wanted the opinion of somebody who knows what they're doing and who has built infrastructures before, who has built cloud platforms before. What they did not want is a fully optimized solution for their product. Despite being a very typical little application and calling for a very typical RDS S3 containers load balancer situation, they wanted to run a couple of VMs, EC2 instances, and a self-hosted Postgres. And in fact, that's how it looked like. That's what it looked like, the architecture. Just a couple of buckets, 2 environments. We did discuss having separate environments, which was already a win. And they were wanting to use S3 and maybe a bunch of Lambdas to do some data processing. And while we were talking, I was thinking about all of the companies that I helped migrate to a more modern, more scalable, more secure, more enterprise-friendly, more something version of their platform, whether or not it was between clouds or within the same cloud, and in which cases it was very easy to do, the migration was very easy, and we succeeded and did it on time, and in which cases it was a lot more difficult. And I tried to steer this engineer in the direction of the easier future, and the idea of this talk was born out of there. A couple of things to get straight from the start. We all start somewhere. It is perfectly fine to have hastily thrown together infrastructures when we just start. That also means that one part of your systems is already outdated, probably today. And if your product succeeds, if you are working on a product on a startup, if it succeeds, you will have a migration in your future. Again, whether it's between clouds or it's within the same cloud or from the data center to the cloud, or you're just modernizing, or suddenly you have a customer in France who wants a location in France and data sovereignty requirements met. It will happen. So how do we prepare for that? And how do we make sure that our future self has it a little bit easier? I'll walk you through the principles and give you some examples. And the first principle is, no surprise, containers. If I'm not going to be talking a lot about this one because it's fairly obvious, even if your product is a little scripty that downloads files from the internet and processes them, containerize it. You're going to need it at some point. You're going to need to move the product, the program, the application somewhere else, and it's going to be much easier if it's already containerized. And I'm going to go as far as saying, split that script into 2. One downloads files from the internet, and the other one picks them up and processes them. And boom, you have a microservices architecture. That doesn't mean that you necessarily need Kubernetes. You probably don't. You might never need Kubernetes. But still, containerize. Even if you're going to run on a VM in an EC2 instance, compute engine instance, make sure that you run in containers. The next one is, if you're just starting out and you want to pick a database, pick Postgres because it is open source, it is very well supported, the community loves it, everyone knows how to work with it, even the data scientists know how to work with it. It's going to be easy. And if anything that you're working with, it does not fit into a relational database, stick it into a bucket. You don't need necessarily caches and NoSQL databases and unstructured data stores. Now just stick it into a bucket, it will do just fine. Whatever is kind of a table and kind of has a relationship and kind of can be queried with SQL, put it into Postgres. Everything else, stick it into a bucket. And if you want to prepare for future use cases around data science or AI or a data lake, you can even go as far as pick Iceberg or Parquet, which is a format of formatting unstructured data when you store it in the bucket. And these formats are really well understood by any data lake situation. So whether you're plugging BigQuery to it or something, or Databricks or something else, Iceberg and Parquet will be your friends. And the fourth one, choose event-driven architectures early. It is very, very, very tedious to try to decouple your services if they have been tightly coupled from the beginning. My little example of a little script that downloads files from the internet and processes them, the one that processes them shouldn't talk directly to the one that downloads them, nor vice versa. Decouple them and do it early. Make sure that your services just output events into some sort of event stream and consume them as well. You use storage bucket, cool. That one also can send notifications about files being added or modified or deleted or whatever. And boom, you have services that talk to each other through an event stream. That said, you don't necessarily need Kafka. I'm not talking about managing Debezium and 3 brokers and whatever infrastructure when you have literally one microservice. You can do very well with the serverless cloud-native solutions, PubSub on GCP, SQS, SNS. On AWS Event Hub, I think, on Azure, you likely don't need Kafka. But if you want to, please do. Be my guest. No worries at all. No problem with that whatsoever. But you don't need to. So let's update that architecture that this engineer from Ukraine was talking about. First of all, we shall containerize. Lambda functions can be functions, native, but they can also run containers. And having a Lambda function and then having to move it somewhere else is very complex because of the abstractions that make Lambda so nice to work with. They also mean that it's very hard to lift that code, lift that function out of Lambda later on. So containerize. Anytime that we're talking with someone who is on AWS and we want to migrate them to GCP, and we're like, ooh, we can see that you have 200 Lambdas. How is that gonna work? And they're like, oh no, they're containerized. Whew. Their migration is gonna be fine. Will be just fine. And their developer team is gonna be just fine. The next one, and let's zoom in to production, only introduce an event stream. So now your files that are uploaded to the buckets are now sending notifications to the event stream. The services running on a VM are sending notifications to the event stream, and maybe the Lambda consumes it. Maybe the Lambda is what is processing those files that land on S3. Cool. And maybe you don't need to run your own Postgres on a VM. You could have a little RDS instance. I think the smallest RDS instances now are like 12, 13 euros a month. So it's really not that much. And you don't need to manage your own database, which comes with a lot of strings attached, right? You need to make sure that your database is okay. And since you would be using actually any database, even if it's self-hosted, but you now have an event stream, you can also have the outbox pattern, which means that all of the transactions of the database are synchronized into the event stream. And you can do whatever you want with that information as well. And boom, just like that, you have a cloud-native architecture that is scalable and portable and really agnostic to whatever you're running that on. And you look like you know what you're doing. Maybe you have listened to some people who we're telling you how to build this. But okay, I'm not on AWS, I'm on GCP. What do I do? The exact same thing. You'll have a storage bucket, you'll have a compute engine. Cloud Run is basically you take a container, you throw it to the cloud, and it runs. It is the most similar that I can compare it to is Fargate, but it's more than Fargate. And it also has functions which are also containerized. And for Postgres, I wanted to highlight AlloyDB just because I'm a big fan. AlloyDB is managed Postgres, but what happens is that it scales compute and storage separately, just like BigQuery. If you're aware of how BigQuery scaled and how it became so elastic and so powerful, same principle, same engine. And you can run analytical queries on your Postgres data. If you know anything about Postgres or any relational database, you really shouldn't be running analytical queries on your transactional database. It will kill the performance, it will kill the database. Well, not with AlloyDB. It is a hybrid engine, and you can run analytics, which means that it caters really well to AI use cases. And PubSub for your event streams. PubSub is also serverless, and it's global, and it has all of the features of Kafka that anybody I ever spoke to uses in Kafka. So no need to manage your own Kafka, but again, if you would like to, please do. It also will mean that you have another open source compatible technology. What if I want to evolve and I don't want to run my VMs again anymore? I want to just run containers. Cool, fun. Just move the containers from the VM to Cloud Run. Easy life, no stress. They scale up, they scale down to 0, they're secure, they have an internet endpoint that can be secured. Easy. But maybe not. And you want Kubernetes. Okay, take your containers, put them on Kubernetes. And your services don't need to be aware of what's going on with other services because you're using an event stream and your database is using an outbox pattern and your files are stored in storage. So everything is decentralized. Wherever you move them, however you permutate the configuration of your infra, fun. It's all good. And if you need to move somewhere else, it's going to be easier. And if you need to grow your platform, it's going to be easier. And if you need to suddenly deploy to 17 more regions, fine, no problem. But that's not all. I'm going to be talking about some other things. And one of those other things, and I should probably stand on this side for a change, security. Even if you're just, again, writing a little scripty, vibe coding, something that's going to take a file and do something with that file, make sure that your authentication is handled properly, that the identities of the services are separate. Each service gets its own identity. Repeat after me. Each service gets its own identity. And they are not static identities. They are dynamic identities. Every cloud provider now has a dynamic identity situation technology, so use that. No static keys, please. Assign roles to groups, not users. I know it's very easy to say, oh, the founder just has owner and he'll sort you out. No. 5 years down the line, you need to clean up a gazillion roles that are assigned to different people, and you don't know who those people are and what those roles do, and do those people need those roles? No. From the get-go, create 2 groups. One is admin, one is developer, and assign the roles to those groups and add people to those groups. No public IPs is another one. Your database doesn't need public IPs. Your VMs don't need public IPs. Your clusters don't need public IPs. If you need to expose your service to the internet, stick a load balancer in front of it. And all of the secrets and configurations and envars and any sort of connection string, put it in a secret manager or SSM or key value store of your choice, and then mount them into the containers as secrets. This is a very, very well-established technology these days, and there is absolutely no need to store any secrets or any connection strings anywhere else. In fact, what I like to do is when we're doing infrastructure as code with Terraform, for the connection strings, for the databases, the code that creates your database instance also creates the secret with a consistent name, a predictable name that the devs will know. Dev Postgres will be the secret of the connection string of the database. Or whatever, if you have 17 different database instances, each of them can have a predictable name, stick it into the secret manager. Nobody needs to know the connection string, they can just pick it up from secret manager. It needs to be predictable names. But first, make sure that you use security everywhere. Everything I just said, make sure that you do. But also consistency. Though for those secrets to be nice to use for your developers, you need to have predictable names. And equally, in everything else, in all of your infra, pick a naming convention and stick to that naming convention. No, nothing like this. Nothing everybody named every resource the way they wanted. Pick a naming convention. The one that I like to use is some sort of prefix. CNS, Cloud Native Summit, is a wonderful prefix. Resource name, my database, application database, my test Postgres 1 to 3 is also a resource name. Region, for regional resources, and environment. So your dev, your prod, your common, your shared, your environments go at the very end of the name. Stick to this, and if you use infrastructure as code, make sure that it's enforced in modules, in whatever. And then, again, your future self will thank you. The person who will come after you will thank you, because you will be out in 6 months, in a year, and the person who needs to maintain the thing that you built, looking at every VPC is named differently and every resource is named differently, will pull their hair out. Whereas if everything is consistent, it will be like, oh, they're using containers, they're writing files in buckets, they're writing data in the Postgres, and everything goes through an event stream, and my resources are consistent. What is this? Beautiful. My life is going to be easy. Best job ever. And we couldn't not talk about AI agents. Everybody's using some sort of LLM these days to help them with their engineering work. And we all know that those things like to generate output that is not always ideal. Most importantly, they like to generate output that is very bare bones, brain dead, standard, whatever, that has no context of your engineering standards. It has no context of how you do things in your organization, how you personally like doing things. So something called harnesses has emerged, and we've been doing it at Zencore internally, where we take all of the engineering wisdom, if you will, and put them into markdown files, rules, skills, etc., for the agents that everybody uses to then reference. We didn't write those rules ourselves. We asked an LLM to have a look at a couple of canonical repos and figure out what the standards were, and then also fed back our own opinions and skills, etc. This has helped immensely because, I work with very, very smart people. And yet in the last couple of months, those very, very smart people occasionally open a pull request where I look at it and think, where is your brain in this? Where are the standards? Why is this completely different from everything else you've ever done before? Well, it's because the agent just wrote something and they trusted the agent. We need to standardize, provide some context and provide the knowledge of the company to the agents for them to be able to output something smart and clever. Or at least attempt to. They also like to ignore those things. So everything I just said about skills and rules and tools and everything. At some point, we spent a bunch of time writing a bunch of skills and rules and instructions, very specific and strict instructions for the AI agents to use Copier, which is a templating tool, basically, to do, if you say, deploy me a version of this service in this region, it will use Copier to generate Terraform and then deploy Cloud Run and all of the resources that are on the service. And then I wanted to test it on a call with a customer, and I'm like, hey, Claude, deploy me this service in this region. And Claude went and decided to analyze the entire repo instead of just being like, oh, Copier command, boom, done. And it took a really long time. And then I asked it what happened. And it was like, oh, I ignored agents.md. Thanks. So these things are still non-deterministic, but you can try. At least it will improve. We can strive to improve as much as we can in this non-deterministic world with tool. Again, it's just markdown files. What we do is bundle them up. They're in a repo. You release some. You make a new release. The pipeline will bundle them up, upload it to a GCS bucket, and then there's a CLI on the engineers' machines that downloads that bundle and unpacks it. It's literally just markdown files and a bunch of Python scripts. That is all from me. Thank you very much for your attention. And if you have any questions, happy to answer.
Any questions?
Probably everybody knows it, but I just want to say, like, you can, what we do is, because the standards are not standardized, there's agents MD and there's Claude MD, and what we do is symlink. So the both, one to the other, and then all the agents know about it. That's the only thing I want to say.
Thank you. So yeah, like a common folder with tools and rules and kind of like a canonical folder, and then instructions to all of the various different agents that we know. Everybody has their own preference to a different agent. Those that Claude MD just says, look in the canonical folder.
Last question, if you have. Thank you again.